Hello everyone, and welcome back to Ewan's Buzz. In today's video, we're going to be covering part 2 of the HP oscilloscope restoration. Now, it's been a while since I've uploaded, and there are many reasons for that. As for one, you can see I'm in a completely different room. So, we'll get to that in a future video. But in this video, we're going to be taking a look at the CRT board and finishing up the restoration I started on the HP oscilloscope. So, let's get started. Okay, so I've got the CRT board out, and here it is. Now, looking at everything, it's looking okay. You know, I'm not seeing anything strange or anything of concern. But I'd say we should start replacing some of the capacitors, especially the electrolytics, as maybe some of them have gone bad. But also then again, okay, these are not bad capacitors, like, as in made by a bad company. They are pretty decent. Some of them are made by Nippon Kimicon, which is a Japanese company. No Rubicons, which is not great, but otherwise we're looking okay. I mean, yeah. So I'd say where we're looking is sort of by the vertical size. So that's sort of this area right here. So I'd say I'm going to take a look at some of these capacitors, and we can see if they are giving us the correct readings or not, as we can connect them up to our multimeter and check. So let us start by taking out these ones here, and just do them one at a time, and see if the readings are the same as on the multimeter. So let me take this big one out first. Alright, so I have got the capacitor out, and it made quite a foul smell. So it might actually be leaking electrolytes, which is interesting. So I've got my multimeter here. Let's check what the capacitance says. So on the capacitor, its rated capacitance is 1000 microfarads at 16 volts. So let's see if it is still 1000 microfarads. We will just gently connect my multimeter up like this. Okay, we're not getting a great connection. Let's see if we can get a better connection. Interesting. Very interesting. Now hold on a minute. Let's just do something like that. Ah. Oh, man. These things can be so hard to test. You have to really get a good connection on them. You know, and then you worry about your fingers screwing the readings up, which hopefully that won't be the case. 1.63 nanofarads, that's really small. Should be higher. Okay, 4 nanofarads. 511 microfarads. It's kinda odd. I would not expect a 1000 microfarad capacitor to be running at half its rating. It's kinda strange. Wait a minute. Oh. It has just jumped up to 1000 microfarads. So it's fine. Interesting. Okay. So this guy seems alright. We thought it wasn't, but it seems okay. So I'm going to basically continue this, removing, checking, and see what I can find. And if I find any bad ones, I'll pause the video and make sure to show you guys. But I will do this in a time lapse. So let's do that. Okay, so while I was checking, I did find a couple of capacitors that did seem suspect. And they also smelled really bad. Particularly this one here, which has been replaced. I think I've got the old one here. I do. And it smells really bad. Yep, this is the one. Don't know why, but it just does. It smells awful. But I've replaced, I think about 3 or 4 of them I've replaced. So let's put it back together and see if that makes a difference. Okay, so I've put the board back in. I haven't put the screws back in because we most probably will have to take it out again, as there might be some other problem hiding somewhere. But let's see what it does. Sorry, my power cable was caught under the chair. But let's plug it in. Okay, 3, 2, 1. Okay. I'm going to turn that off. Give me a second. Because if you do wire capacitors the wrong way, they can tend to explode. So it doesn't damage anything, it just makes a loud bang. So I'm just going to prepare myself. There we go. Now let's try. Oh my goodness, we fixed the problem. It was just bad caps, I knew it. This is incredible. Now let's leave it for a little bit and see if if any of them pop, because if they do, then I probably put them in backwards. But would you look at that? I fixed the problem. You can see me with my hearing protection on in case one of them explodes. But we'll certainly know if it does, because it will make a loud bang and a lot of smoke. But would you look at that? We fixed it. Ha! There we go. That looks so much better. Now we just need to, sort out the size and all that. But judging by the fact I've left it for this long, I'd say we can turn it off and put the last screws back in. So let's do that. Okay, so the board is back in and tightened down. So as you can see, the screen, well, as you saw in the last little clip, the screen was a little bit off. So we're gonna just quickly calibrate it. So I'm gonna show you how to do that. So basically, how I figured out it was the capacitors is, first of all, capacitors, they go bad. They're a known cause for causing things to break. And well, I thought if it's a bad capacitor, then it would probably be by the vertical hold circuit, as it looked like the image was just about to collapse in vertical collapse, which is when you lose the scan lines that keep it vertical. It's usually for the yoke that keeps because the electron gun, it scans across the screen like that. But what happened in this case was it was getting really small. And as soon as I smelt that capacitor, it didn't smell right. And also I sort of looked by the vertical hold side of the board, which gave me the answers that I needed. So that's why I started there. So now we gotta calibrate this guy, as new capacitors means better values. So let's calibrate it properly. Okay, so the CRT is perfectly calibrated. I've sat down for quite some time and just tweaked it and calibrated it. So now it is all good. So there's a couple things that I just want to check before I put it back together, and I was thinking, remember this capacitor that I replaced right at the bottom here? This little guy right here? I was thinking of doing the other ones as well. As just for accuracy reasons, I think it'd be a good idea just to replace those other ones as well. As I have got 4 replacements that are brand new as well, so it's not like they're old or anything like that. So they're brand new and they will be accurate as well. But what I thought we should do, let's just bring it back down, turn it on, and make sure the calibration stayed. So when you look at that, it did. That's brilliant. I'm super happy about that. Now, I was originally confused about this little space at the bottom, and in the camera it looks kind of skew. I'm unsure as to why, but in person it looks really good. But at the bottom here, as you can see, is it skew? No, I don't think so. I'll take a look though. I don't think it is, but hold on, let's check. Oh yeah, it is kind of skewed. Let me fix that quickly, and then I'll bring you guys back. Okay, so after some more calibration, I just sort of had to sit down and really pay attention to what I was doing and calibrate it properly. Let me show you how it looks. So it should look okay. I hope it looks good. But there we go. It's looking alright. Looking alright. Now if I go to, let's say, a mode, for example, now you can see what that empty space would be used for at the bottom. Let's see if I hold it up, you can kind of see what it's doing. It looks a lot better than it was before, I can assure you that. So now what I'm going to do is I'm just going to turn it off, and we're going to take a look at those capacitors. So here are the new ones that I've got. I've got 2 of these ones, and then another one that's hiding somewhere here. There it is, on top of the Dremel bits, and another one here. They're all the same, so I'm basically just going to replace all those ones that I replaced before with these little guys. And then we should be good to put it all back together. Glad the CRT's all sorted. That I was a bit concerned about, but now that's all sorted. So let's put these caps in. Okay, so I've put the new capacitors in, you can see them right here, and I did do a couple of power on tests just to make sure that it was working right, because one of the tracers actually broke, or not tracers, but the pads actually broke for one of these capacitors, so a little bit of super glue, put it back on, had to refine the pad, had to scratch away some of the lacquer on the trace, just so I could join it up. But that capacitor is all good. I would have preferred them to all look nice and neat, but that one's just a little bit, how would I say, different. But it's on there and it's working, so we'll leave it be. But it's working good, so these capacitors have been replaced, and you can actually see just how tiny the other ones were. They literally fit on my finger. Pretty crazy. And these were running at about 15 to 11 volts. These are all 50 volt capacitors, so there'll be more than enough to handle, what was this, but whatever the voltage spikes or whatever voltage occurs here. So they'll be fine. So CRT is calibrated, Dallas chips in, capacitors are sorted. I'd say we can put it back together for real now. And then we can clean it up. So let's put it together, run some tests, and give it a clean. Okay, so the oscilloscope's all back together. I've got it hooked up to a function generator I repaired a while ago. Let's turn it on. First the oscilloscope, and then the function generator. Now, we'll set the function generator to generate 1 mega ohm, and we want to do a sawtooth wave. And we'll set it down to its lowest frequency. There we go. And we'll select channel 1 and channel 2. There we go. And now we can adjust the position of them both, like so. Channel 1 and channel 2. Alright, now okay, we'll reduce the amplitude there. And let's go to our trigger. We want it in auto, yes. And we will go auto scale. There we go. And now you can see we've got two really nice looking sine waves on here. So, going to probe 1, we've got it on 10 megahertz. And then probe 2 we'll also put on 10 megahertz, as that's what I currently have them set to. But here you go. It's working very well at that. So let us try change the frequency a little. Ooh, ain't that pretty cool, eh? Oh, that's pretty big. So let's do an auto scale. And we've got a sawtooth wave, which is what we originally had. Well, there. Yep, there's our sawtooth wave. Then we can go look at a sine wave. And the volts per division on this one is a little bit high. Well, there we go. We've got two nice looking sine waves. So let's look at channel 4 and channel 3. So we'll click onto channel 3 and just unplug that. There we go. So let's turn channel 1 off, channel 2 off, then channel 3 and 4, and let's go auto scale. And there we go. I must just change the volts per division for channel 4. Just give me a second. Okay, I need to figure out how it works for the other channels, but as you can see, channel math, this thing can do a whole lot of stuff. I just need to figure out how to change the volts per division on the other channels. But yeah, it is working. It's working really well, actually. You can see, it's nice. It's showing us two different waveforms, and we can see them both changing, which is really cool, actually. So let's see if I can change the volts per division for number 3. Oh, we just lost our signal because my setup may or may not have popped out of the function generator. There we go. Just give it some help by holding it in. There we go. So let's see, channel 4. Okay, there's our time base. Okay, this scope, I will need to do some learning on it, that's for sure. This is very advanced, but it's really nice because none of my scopes aren't working at the moment, so I can use this one to take a look at some of the waveforms that I can see
out of my function generator. I was using a very basic oscilloscope that I was lent when I was doing this, fixing the function generator, but now this one is reading my function generator output perfectly. So let's clean it up. And there we have it. It's all cleaned up and fully restored. This HP oscilloscope is ready to work once again. Now, this was really, really special just for me to do, and just for something to have to almost memorize Roger. He's never going to go from my memory. And it's sort of just nice to know that this was something him and me technically worked on. It was sort of like a group project. I suppose you could say it like that. He will be missed very, very much by me and his family, and anybody who really knew him, as he was an amazing guy. But it's good to know that a piece of his equipment is working once again. And, well, I hope if he ever sees this video, somehow, in some way, that he'll be proud. But let me show you some of the things we had to replace to make this repair possible. So, first of all, the bad CMOS battery. Well, not CMOS battery, RAM battery for the Dallas clock chip. To replace that, so this is the old one. Then, quite a few capacitors actually. There's some little ones, this big one which made an awful smell when I took it out. I don't know if I mentioned that. Then we've got this one as well, and this other one here. So these were the electrolytic capacitors we had to replace, which is about 4 of them. And we put some high quality Rubicons in there. Now these ones don't look like they're broken, but they are most certainly still bad. Then some SMD capacitors, which I cannot pick up as they're just so tiny. But that's it. I hope you all enjoyed, and I will see you in the next one. Bye bye.